Okay, so as with any project, the first thing you want to do is take a look at the print and figure out your order of operations so you don't work yourself into a corner. I think this is a pretty simple one. I think probably the first thing we'll do is saw out the stock. I think I have some 3/4 inch steel plate around here. Mild steel plate. This part's going to be carburized or case hardened, carburized and hardened when it's done. So it can be low carbon steel. Definitely needs to be steel because there's a lot of friction between the knurl and the holder, and if it's hardened steel, the tool's going to last a lot longer. Let's see. So I guess we'll saw the part out, and then we'll square it up, all 6 sides. And probably the next thing we'll do is probably cut these 45-degree chamfers on the one end. Then we'll set it up on end and cut this slot for the knurl. And then the last operation will be reaming this dowel pin hole. So let's get started here. We'll get the stock out and get some parts sawed out. Okay, so I got a piece of steel here, rusty old steel, 3/4 of an inch thick. We're going to end up with a 5/8 part, so I think I'll probably cut it out about 3/4 square. I like to use Sharpie because it's easy to see. So let's just put a mark 3/4 from the edge. We'll saw that out. And then we'll cut it. Let's see, what do we got here? It's 3 5/8. That's going to be a little tight. Let's do it this way, 3 7/8. Let's do it this way. Make sure we have enough stock on the length of them. So we'll saw it out this way. And then we'll divide that in 2. 3 7/8. About halfway. Okay, that'll leave plenty of stock. 8 3/4 to finish. We're about 1 7/8 now. That's good to go. Let's get it sawed out. I'm going to have to slow this down a bit. I usually set up for aluminum, so we'll run it all the way down. I got about a 5 tooth per inch blade in there. That's fine on material this thick. You always want to have at least 2 or 3 teeth on the material at all times. Got a pair of safety glasses and get started. Grab a push stick here. It's a little more comfortable than pushing on the steel, and it protects your fingers a little bit. This is going to take a while, so I'll cut the camera off and finish it up, and then we'll start squaring up the part. Alright, we're just about done here. Had a little time to think about things to mention on this. It never hurts to talk about safety. I like talking about safety. And so, as I pointed out in some of my other videos, when you saw on a bandsaw, don't get your hand in line with the blade, or your thumb. If you slip, then obviously you can put your hand or thumb into the blade. Believe it or not, I've seen that happen before. It's not a pretty sight. So, you use a push stick. For sure, use a push stick. Get your fingers out of the way, and always keep your hands on each side of the blade. So if you slip, you go by the blade rather than into it. It's common sense, but you know, a little bit of common sense will save you a lot of grief in the shop. Another thing I like to mention is this blade. I made a video a while back on brazing or silver soldering bandsaw blades together. This is still the blade that I made up in that video. It's been months and months of use, and it's still going strong. So I'd just like to point that out in case anybody had any doubts about how strong silver solder joints are in bandsaw blades. Also should have mentioned the cutting speed on this. This is mild steel. Cutting speed is about 100 surface feet per minute. So however your particular bandsaw is set up, that's the speed you want to end up with, about 100 surface feet per minute. Any slower than that, you're wasting time. Any faster than that, you're burning up your bandsaw blade. Another thing I thought about during this cut is when I finish this cut, I'm going to start squaring up the stock. I'm not going to cut the parts in half. I'm going to leave them connected end to end. It'll be a lot easier to machine. Whoops. Yeah, I just threw my blade off anyway. So I'm just going to throw this in the mill and square it up now to 5/8 square, and we'll machine the ends square on it. Then I think I'll go ahead and cut the chamfers on each end, because it's a lot easier to hold on to a big part like this than it is to a smaller one. So when we get it squared up, get the chamfers cut, then I'll cut it in half, and we'll mill the slots and drill the holes after that. So it's just, you know, a little easier to hold on to a larger part like this. So we'll hold off on the cut, you know, cut them in two. So let's move over to the mill and do some squaring. Okay, so let's get this piece of stock squared up. This rusty old piece of steel. I like to use fly cutters for squaring up stock rather than end mills, because the rust on steel really eats up cutters. So I'd rather dull a fly cutter that I can resharpen than dull an end mill that I'd have to replace. So I always use fly cutters for squaring up stock. It's just something I do. So we'll just set the part on a parallel so we get as much of the part gripped as we can and still have enough room to machine on top. It doesn't matter which side we start with; they're all rough at this point. I always like to use a piece of aluminum wire between the movable jaw of the vise and the part, just to get better contact. Big burr on this part here. Let's use a different side. There we go. So let's figure out the RPM for this fly cutter. You guys remember the formula for RPM is 4 times the cutting speed of the material you're cutting divided by the diameter of the tool. In this case, the diameter of our tool is about 2 inches. This fly cutter. So 4 times the cutting speed of steel, which is 100, is 400 divided by the diameter of the tool, which is 2, gives us about 200 RPM. So let's dial this in at 200 and do some squaring. Make sure I'm away from the part before I turn it on. That's a little faster than 200. Switch into back gear. 200 is right about there. Okay, don't take any more off than you have to for the first cut, just enough to clean it up. You don't want to go too far and then have the part not clean up on the other side. So we just kind of sneak up on it until we clean up all the, in this case, until we clean up all the saw marks. Just bringing the table up a little bit at a time until all the saw marks go away. Speed this up a little bit. Fly cutter you can get away with a little faster RPM than end mills. Because the tool doesn't heat up as much because there's only one cutting edge, unlike 2 or 4 on an end mill. So it tends to scan the little faster RPMs better. Fly cutter like this, it's a good time to check out and make sure the spindle on your mill is trammed properly. If it's not perfectly vertical, you'll end up with a pattern that's not crisscross like it should be. If you look at this pattern on this tool is making it into work, it's a nice crisscrossed pattern. It tells me the spindle's perpendicular to the work. Alright, so now we have a machined edge to work from. So now that's the edge that's going to go against the solid jaw of the vise for the next cut. We still don't need to hammer it down because we're still have a rough edge against the parallel. So it's just parallel's just there to hold the part up in position. It's not really there to locate it precisely yet. Alright, so now I'm just going to take another cut at where it's set. And it's not quite down far enough, so we'll creep down to it. This side's fairly straight. It's a rolled edge versus a sawed edge, so it should clean up without taking much off. Okay, so that's 2 edges. Now we have 2 sides perpendicular to each other. Okay, so now this is the first edge I did. I'm just going to rotate the part 180 degrees this way, keep that first edge against the solid jaw. Okay, now we have a finished edge against the parallel, so this time we're going to have to hammer the part down against the parallel. Still got a rough edge against the movable jaw, so I like to keep a wire in it. Okay, so tighten it down, and for hammering down a rough steel part like this, or any part, I just use an ordinary ball peen hammer. And by tipping it a little to the side, don't use the face, use the edge of it, it acts just like a dead blow hammer. Okay, you can put your fingers on the part and hammer it down, and you can feel when it seats on the parallel. Okay, and since we're roughing, this is a rough surface, we don't really care if the hammer marks the part up, doesn't matter. Okay, it's just a quick and easy way to hammer a part down. I catch a lot of flack for using a ball peen hammer. They say, oh, you're marking your part. You should use a dead blow hammer because the part jumps up. And well, it doesn't, okay? All you got to do is hold the part when you tap it down. You can feel when it seats on the parallel. If you hit it flat, like this, then yeah, it might bounce off the parallel. But by using the edge, it acts like a dead blow hammer because it dents the material, right? So that absorbs a lot of the energy and it turns it, takes it from a sharp blow, turns it into a push, pushes the part right down on the parallel. Works great. See how tight that parallel is? Okay, no more flack about ball peens. They work great. Try it. All right, now so we have a lot of. I know we have a lot of stock on this part, so I don't have to be too careful. So we'll take off like 20 thousandths here, and then I'll measure the thickness. We're shooting for 0.625 plus nothing minus 3 thousandths. Okay? A lot of my parts have tolerances on where the size is critical, where we have to have clearance. Like in this case, we have to have clearance between this knurl holder and the slot that it mounts in. So if we don't have tolerances, we can't guarantee that there's a clearance. It might be a tight fit, or it might be too loose of a fit. So we use a tolerance on here to control the fit between the two parts. There's no sense waiting for the thing to finish cutting, because we've got to go back and take another cut anyway, so we'll just move it off the part, take a measurement, and see where we're at. And we'll do some serious cutting. Okay, we are at 733 thousandths. Okay? 733. Alright, and then we want to go to 625 minus a little bit, so let's just go, we'll call it 0.625. We have at least 108 thousandths to go. And then to meet the tolerance, we'll have to go, well, half of that tolerance range is about 1,000th and a half, so we'll have to go about 1,000th and a half deeper. But right now we're going, we have to take 108 thousandths of stock off. So let's see what we can do here. Set my dial so I end up on 0. I always like to set the dial before I take a cut, so when it's finished it ends up on 0, so I don't lose track of where I'm at. I think I'm going to take, I don't think I can take the full 100 off in one pass. Let's take about half of it. That may vary with your machine, okay? If you have a light benchtop mill, you might not be able to take that much off. There. It feels pretty good, so that machine's not struggling. So with that, I'm going to go to full depth. Stop about 10 thousandths short for finished cut. See if it'll handle the full 100 thousandths. Alright, I saw my spindle slip a little bit. So let's make sure nothing moved. Let's tighten it up a little more. Steel puts a heck of a load on a machine. I'm going to drop it down, and I'm going to take another trial cut just to make sure my cutter didn't move on me. Actually, let's see here. Yeah, looking at the dial, it did move a little bit in Z, so I'm going to take another cleanup cut to reset my, my dial. Better to find out now than after you get the part almost down to size and go under a little bit. Alright, gives me enough to measure. Let's see where we're at again. Okay, we are at 726 thousandths. 625 minus, we have 101 thousandths to go. I set my dial so I end up at 0 after moving 101 thousandths. And we'll go down, leave about 10 thousandths per finished cut. And hopefully it won't slip this time. That's better. Now you can see the chips coming off kind of a straw color. That's about as hard as you want to push it. If they start coming off blue, your tool's liable to fail before you get your part done. You see these are just starting to turn a little bit of blue here. That's about as hard as I can push it. These chips are straw colored on one end and blue on the other, so we're making it work pretty hard. Make sure you have safety glasses on using a fly cutter because it throws chips everywhere, and they are hot. Since waiting for it to finish out, we still have a finished cut to go on it. Okay, now if I take off another 10 thousandths, theoretically I should be at 625. And since the tolerance is fairly tight on this, I'm not going to do that all at once. I'm just going to take a trial cut of 5 thousandths and check it before I go down the rest. It's a lot easier to take more metal off than it is to add it back. You always want to make sure that you don't go too deep on your cut. Okay, that gives me enough to measure. Now we can take one final measurement, move down the rest of the way, and take a finished cut. Let's see where we are here. This should be, what, 630, right? 5 thousandths shy of 625. Okay, and that's where we're at, 630 on the button. So now I want my finish dimension to be 625 minus half of the 3 thousandths tolerance, so I want it to be about 620 2.5 or 3.5. So that's 2.5 or 7.5 thousandths farther, right? 5 to 625 plus another 1.5. That's 6.5. Okay. So let's crank the table up 6.5 thousandths. Take finish cut. Make sure our cutter's going the right direction. See, I bumped the feed up a little bit now because we're not taking as heavy of a cut, so we can take a little faster feed. Don't want to go too fast, that'll give you a rough finish. Kind of a balancing act. You just got to kind of pay attention to what you're doing. Adjust your feed rate accordingly. I get a lot of questions on how to figure out feed rate. Well, this is how you do it. You just look at what's going on and make adjustments. If you had, if this was a commercial part and we had machinery that we could accurately control the feed rate, we could calculate the most ideal or the ideal feed rate out ahead of time. But for stuff like this, you just do it by the sound of the machine, the look of the chip, and what you're doing. Alright, so this should be 625 minus 1.5, 623.5. We are at 624, okay? And that's good. We're under the 625 nominal dimension, and we're not 3 thousandths under it. So we're between 0 and 3 thousandths less than 625. So that's a good part. So we're all set. So now we have 3 edges or 3 sides of this part machined. Okay, and all square to each other. Now we have one more to do, so we'll just flip the part up vertical here. We don't need the wire anymore. We have a finished edge down. Our original edge is down now. Make sure these burrs are off the end. Part this narrow, you don't need 2 parallels. Okay, if this part were 3 or 4 inches wide, then I'd use a second parallel. But something this narrow, 1 parallel is fine. Okay, hammer it down. Okay, parallel's nice and tight. So now our dials are all set. In fact, I'm going to go down here, set my dial on the table back right on 0, so I know exactly where to go now that we have the tolerance all figured in. So I'll back off 10 thousandths. And we'll take 1 roughing cut and 1 finishing cut. Feeling pretty heavy, so I'm going to back off a little bit on that. Taking about 50 thousandths cut or so now instead of the 100. Why it's different than the first time. It's possible the tools start to get a little duller. Should be good enough to finish up. Then we'll stop and resharpen it. Since waiting for it to finish out, since we got to take another cut anyway. So. And now stop 10,000 short of the finished depth. This will be a second roughing cut. It's not quite as deep as the first, so I can speed up the feed rate a little bit. Getting bombarded by chips over here. Now we can take the last 10 thousandths off and this should be good to go. You could do the same thing this time that I did the first time through and stop 5,000 shy, take measurement just to verify the depth if you want. It wouldn't hurt. And I have enough confidence in my setup and my machine here that I'm going to skip that stuff. But it wouldn't hurt to take another measurement before you take it down to size. And hopefully it doesn't bite me in the ass, but we'll see shortly here. Alright, let's see how we did. 625 minus 1.5 thousandths. We are 624. So we're almost right in the middle of our tolerance. So we're good to go on this part as far as the 625 square dimension. Alright, so now we have to, where are we at? There we go. So now we have to machine the ends. So I'm going to, rather than use a fly cutter and squaring the thing up, I'm going to use an end mill for that. I mean, I could do it with a fly cutter. Okay, you'd have to put the part in like this and square it up with a solid square. But if I do this, look how much is sticking up above the vise. That makes me a little nervous. Okay, that tends to move the part. So I'm going to switch. Okay, battery just went dead, but luckily I caught it. So like I said, or I don't know if you heard that or not, but I'm going to use an end mill to finish the end of the part rather than stand it up on end in the vise and risk the part moving. So let me go grab an end mill and we'll mill the ends. Okay, got myself a 1/2 inch end mill here. Swap that out for the fly cutter. Okay, now we're going to have to change the RPM. Now instead of dividing by 2, we divide by 1/2. So 4 times the cutting speed, 400 divided by 1/2 is 800 RPM. So we don't need to be in back gear anymore. Speed it up here. Set our speed at 800. And now I don't care about the any dimensions here because all I'm doing is cleaning up the end, making it square. Because we still have to cut the part in 2 and finish the opposite end. So let's just set it on a parallel here. Okay, now really this should be hammered down. Just to make sure it's not going to make a huge difference in the squareness of the end of the part, but it's just a good habit to get into. But now we use a plastic or a brass hammer because we don't want to mark this surface, right? No ball peens at this point. Alright, 800 RPM. Here's a good example of climb milling versus conventional milling. Okay. If we go this way, that's climb milling. The cutter wants to climb up on the part. You have a light mill, you probably shouldn't be going this way. Okay, if we go this direction, the cutter is tending to push the work away from it. It won't climb up. It's good to take a roughing cut conventionally, and then just a finished cut climb milling. Finished cut tends to produce a better finish. So, if you have a light machine, just take a couple thousandths finished cut. But climb milling, you see a lot better finish. Just be careful about taking heavy cuts when you climb mill, because the cutter can literally climb up on the work and bite into it and break the cutter or move the part. Okay, where are we at here? Okay, we got a nice squared up end. Do the same thing to the other end. Again, I don't care about the dimension here. Make sure the parallel's out of the way. They don't cut very well. Rough cut, conventional mill, rough cut, climb mill for a finish cut. Make sure everything's cleaned up. It is, so we're good to go. Alright, so all squared up, all 6 sides. Let's move over to the bandsaw. Let's see, should we do that now? Why don't we cut the 45-degree chamfers now? Let's see, do I want to do that? Let me think about this a little bit. No, let's cut it in half at this point. It's all squared up. We got the benefit of leaving the parts uncut for squaring purposes. So let's saw this in half and then move on to the last operations. Okay, I got them cut in half. I spared you the misery of having to watch me saw it, do any more sawing. So now we just need to finish up these ends. I'm going to do these both at once. Show you how I'm going to do that. Just going to set them on end on a parallel, centered in the vise. Stay away from working at one end of a vise like this, because when you do, when you tighten it down, the movable jaw will tilt and it won't grip the part evenly. So I always work in the center, and just to make sure it grips well, I like to put a piece of paper between the movable jaw and the parts. And I'm not going to rely on that skinny little squared up end to align the parts. I'm going to use a square, so I'm just going to push the parts against the solid square as I tighten up the vise, just to make sure they're vertical. Okay, now this is going to be a finished cut. We're machining these to length now, so let's make sure they're tapped down. Again, I just rest my finger on the side of the part when I tap it, and I can feel when they go down tight on the parallel. So we'll just use this 1/2 inch end mill. Let me zoom in a little bit here so you can see what's going on better. Something I want to point out. Okay, down against the stop. Just run down until we pick up the end of the part. All right, now. You want to be careful about milling parts that are clamped in a vise like this with an end mill, because if you come in against the end mill like this, the end mill wants to move the part sideways, and since it's really not solidly supported sideways, it can rotate in the vise. So it's better to feed into the part in this direction, or from the other way. Now feed into it this way. So now when the end mill touches the part, it's pushing the part sideways against the solid jaw in this case. And there's no chance that it's going to tip. It's one of those things to watch out for. So now we're just going to take a clean-up cut on these. Now we can take them out and measure them and see how much more we have to take off. Okay, our finished dimensions 1.75 inches. You can see that. Oh, that's really close. Let me back out a little bit. Okay, the length is 1.75. Notice now the length is a 2-place decimal. It's not as critical. Look down here in the title block. 2-place decimals are plus or minus 15 thousandths. So anywhere, 15 thousandths on each side of 1.75 inches is good for this part. So where are we at? Let's see. We are 1.880. Okay, you can do this in your head, but I always like to use a calculator. Just to keep from making mental errors. So we have 130 thousandths to go. So let's throw the parts back in. I'm going to deburr these and make sure there's burrs don't get in the way. Still going to use the paper. always use paper just to make sure that the part doesn't move on me. Okay. And we can still use the ball peen because we're not working on a finished surface. Alright, 100, what did I say? 130 thousandths. Set my dial so it ends up on 0, and after I raise the table 130 thousandths. We'll leave 10 thousandths for finished cut. And let's cut some steel. Notice the color of the chips. No blue chips here. They're all silver or slightly straw color. I don't want to see blue chips in an end now. They don't tolerate the heat as well as the fly cutter. Alright, that's the rough and cut. I'm not even going to check it because it's a two-place dimension. It's not critical. We'll take it right down to size. Alright, so that's done. Now, I'm not going to take these out. We'll leave it right in here. And we're going to go ahead and cut the groove, the slot.